Okay, here it is our, we can find our, is it okay? Should I shut it down? Hey, I will delete list run local. I will delete it. Okay. And today's lecture note download. Finally, I have to log in again. Huh. Oh. Finally. Stupid. Oh my God. What happened? So that's where we end last week. Okay. The age of 50 billionaire listed by Forbes. Okay. And hey, when we obtain this figure, it is not the end of your job. It is on the contrary, the beginning of your job. Why? Don't think that oh, I got this figure, so I can stop and go outside for fresh air. No, it is just the beginning of your work. Why? Because you have to make some prediction based on this figure. You have to draw some implication, draw some suggestion from this figure. So what is the suggestion we drew last week? What is it? Hi. Um, three category. This, 1, 2, 3, and also or this three category. This, 1, 2, 3, or this 1, 2, 3. Hey, which three categories have the biggest proportion? Which one? These three, or these three, or these three? Which one? Last combination of category. What is the percentage? Does what is the percentage do the these three category take? What is the percentage? It's 68%. Okay, and the most of the billionaire have age between 45 and 71. That's the implication we drew last week. Okay, when you obtain this conclusion, this implication, when you can you make an inference, then it is the end of your job. Okay, because it is the figure is too the information in this figure is a little bit small. a little bit little to make big, too little to make a big inference, to make a big implication. So when you have make such a prediction, okay, oh, 60% of the billionaire have age 45 to 71, and those older than 81 or younger than 44, the percentage, okay, is very small, okay, and you can say this is a distribution of the age of the billionaire, okay, and those too old and those too young are the proportion of those too old or those too young are very little, okay. Most of the book of the billionaire has age between 45 to 71, and hey, this is the distribution of the age of those billionaire, and in fact, the shape, this kind of shape is called bell shaped. Bell, you know, the church, the bell shaped. Okay, bell shaped distribution is the shape of the most of the distribution in nature, right? Most data set have distribution like this, bell shaped. All right. And do we have other shape? Yes, we have a skewed shape, skewed, like this. The shape of the distribution of the age of the 50 wealthiest people is the bell shaped. Okay, in fact, the shape, the bell shape, this bell shape, this shape is the shape of most data set in nature. Or you can say on Earth. Do we have other shape? Yes. Let me show you. Like this. Here. If you see this shape, have you ever seen this shape of distribution? What is the shape of this distribution? It is right skewed. Distribution. What is the, so for example, the distribution of the statistics. Score, right? Why? Most of the students have made, like most of the students have low score in, statistics, okay? Not only in Tam Kang University, but also in a university of everywhere on earth, okay? So what is this? Have you ever seen this kind of distribution? Distribution of this shape? Too many. Yep, here. This is called left skewed distribution. Or left skewed distribution. For example, the distribution of film art. Or you can say movie. And you enjoy movie every week. And you like to see movie. And maybe there is no examination, midterm or final. No, neither midterm nor final. And all you have to do is to submit final term report. Okay, and the teacher is very happy because he was enjoying the movie too with you, so he's very happy, very good in mood. So the score they gave you is very high. Okay, most of the student have, the bulk of the student have very high score. Okay, of the score of the film art. The score of. Okay. Of film art. Okay. What? What? Okay. Um. Now, please go to the next example. Where is it? Page on page On which page? Please go to page 47. 47. Example 2-2, record high temperature. How many states are there in the United States? 50 or 51, I think. If Alaska and Hawaii is not included, were not included. And I don't have time to write all the 50 states record high temperature. I don't have time, so I only do part of them. Okay, how many columns do we have in your textbook? 10 columns and 5 rows. So totally we have 50 states record high temperatures. Okay, and if you report the 50 record high temperature to the president of the United States, he will not be grateful to you because he's so busy. Okay, and he cannot have any idea from these 50 numbers. Okay, and what can you do? You have to make some summarization and visualization of this data. So how to summarize? How to visualize? We can summarize this data by, okay. This is the textbook's raw data, right? And I sort them in an ascending order. This one is not 100, but it is this one is not 104. This cell, in this cell it is 100. A typo. Typo means typographical error. I'm not sure if it is correct. I'm not sure. Typographical error. It is not 104. It is 100. Okay. And I rearranged them into an ascending order from low to high. And okay, based on the raw data from your textbook. Okay. And I said, the president of the United States cannot have any idea from this figure, sorted or not sorted, okay? Because he's so busy, and a number is so tedious. 50 numbers are so tedious. So, oh, sorry. Range. So what is the range? Range is the difference between the maximum value, maximum record high temperature, minus minimal record high temperature. So what is the range? The range is 34. Suppose that we wanted to classify this data, these 50 numbers, into 7 categories. That means we have 7 classes. We want to have 7 classes to classify them, and then we have 7 classes, each with length. To be corrected, each with length 134 minus 100 divided by 7 because we wanted to have 7 categories. So each category each class has length 4.9, and then we are round up to 5. Okay, to the next integer 5. Okay, and the range should, in this case, if each cell has length 5, then and you have 7 classes, then the total range should be 35. So here it is 34 from 100 to 134. Now the range is to be 35. So we have one degree, okay, extra 1 degree. So this one take 0.5, and here we add 0.5 again, so that totally we have 35. Hey, here from here to here we have 35, and by doing so we have 7 class, and each class has width how many degree? 5. Totally 35. 7 classes, and each class has length 5. So totally we have 35 from here to here. So what is the lower class limit of the first class? Then it should be, hey, this is 100 and 0.5 here. Go back by 0.5. So it is 99.5 and 134.5. Okay, and now we can now divide them into 7 classes. So that's the 7 classes, and the class limit of the 7 classes are 1, 2, 3, 4, 5, 6, 7. The first class has 2 limits: lower class limit and upper class limit. Here, the lower class limit and the upper class limit. And upper class limit. Okay. So how many frequency count do we have for the first class? We have 2 observations, 2 states record high temperature lie between 99.5 and 104.5. 2 states, but I don't know, but we don't know the name of the 2 states. Okay, whatever. And how many frequency count is there? How many states has record high temperature between 104.5 and 109.5? How many states? 8 states. Okay, and how many states in the United States have record high temperature between 109.5 and 114.5? How many states? 18 states, based on the Rotate-Hanyur test book. Okay, and it is very hard to count the frequency based on the rotate. So hey, you have to sort them into an ascending order or descending order, like this. Hey, from low to high. 100, 105, 105, 105. Okay, and then 106, 107, all the way up to 134. Okay, and up, and here, this word is then, it is not they. It is not they, it is then. Then we have Okay. Here. And okay. Suppose that we do the frequency count all the way to the for the first and the second class and the third class, and we do the frequency count all the way up to the 7th class, and we finish arranging the data. Here is a table of frequency count, and we call this a frequency distribution. So a frequency distribution is a table that describes the frequency count of different classes, right? Different classes, and now we have some feeling, we have some idea. We can have some idea from this table. If you have time, if you have more time, then you can plot a histogram. Hey, we call this histogram, to visualize the distribution, the table of the distribution, to visualize the distribution, okay? And we can have idea better using based on the histogram than the table, okay? So in general, this bell-shaped histogram is the shape of most frequency distribution. Like I said, it's bell-shaped. Is the shape is the distribution of the most data set in nature. All right. And now, hi. So, what is the definition of the histogram? The histogram is a graph. It's a graph that displays the data by using contiguous vertical bars. Okay, unless the frequency of a class is 0. Is a graph that displays the data by using contiguous vertical bars of various heights. Each bar has a height, which displays the frequency count of a class, right? Okay. Using contiguous vertical bars of various height to represent the frequency of the classes. Okay, and to be more specific, the purpose. So what is the purpose of a distribution? The purpose of a histogram is to represent the frequency distribution of a data set. All right. The purpose. Hey, what is the purpose of a pen? What is the purpose of a pen? We invent this pen for some purpose. We can write, we can draw based on the pen, using the pen. So if we invent, human being invent a thing called a histogram, there must be a purpose for it. Okay. So what is the purpose of the frequency of the histogram? Is to represent the frequency distribution of a data set, or you can say to visualize. Or you can say, oh, visualize. To represent or visualize equivalently. To visualize. The frequency distribution of a data set. So in this example, the record high temperature of 50 states of the United States of America it in this example is a symmetric, or we call it a bell-shaped histogram. Is there any other shape for a distribution? The answer is yes. It can be the distribution can be right skewed or left skewed. So this kind of histogram, this shape of histogram, a histogram with this shape maybe is the distribution of the score of what? Statistic or film art? What? Statistics. Most of the students score very low. So so miserable. They score very low because statistics is so hard to learn, right? So what is so it represents the distribution of film art because most of the students score very high. Why? Because they enjoy movie all the time. Every time they attend a class, they enjoy the movie. The student is happy, and then they know what the movie is about because the movie is very interesting. Okay, and the teacher also enjoy the movie too, so he's also happy all the semester. So when he grade the student's performance, oh, he or she, the teacher, he or she give the student very high score, most of them. Okay, so it is called left skew. And do we have a histogram or distribution of this shape? Do we have distribution of this shape? Yes, M-shaped, capital M, M-shaped. The distribution of house price in Taipei. Why? No, no, no. The distribution of house area. The area inside the house. Why? Hey, because the price of a apartment in Taipei is very, very expensive. So young people, young couple, young people, young guy, men and women have limited means to buy an apartment. So they can only buy small area apartment. Most of them, when like you, well, when you graduate from Tamkang University and you wanted to buy a house and you have limited means to buy a big one. And then most of you, including me, I can only enjoy small area apartment. And and what about this? There are also many rich people in Taipei. They enjoy big area apartment, right? So what happened to the middle class is missing in Taipei, in Taiwan. Now I think it is not it is the phenomenon is not limited to Taiwan. It also prevail. The missing of middle class is also prevail in other country. All right, like China, like Japan. You know, so very few people buy. There are no middle-sized apartment available in Taipei, maybe in Tokyo or in Hong Kong. Okay, so we call this M-shaped, right? So there are many possibilities of the shape of a distribution. Okay, we will see later in the later sections. So 10-minute break. Yep. Yeah. U-shaped. Oh yeah, Sam. Oh, in your textbook is called U-shaped. Good. Good. 你要找我吗？ Hi. Hello. 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 Hi. Hi. Please be seated. I need some time to use the i- uh, yep, here. Hi. Hi. Um, we have in the example we see 50 states record high temperature, right? And I believe 50 the sample size 50 is too little, too small to demonstrate. And I'm now giving you a sample as big as 10,000 data, 10,000, right? To visualize what happened. Okay, and suppose that we are in the next example, which is not available in your textbook. For example, the height of TKU girl student, and I will generate some pseudo random number. The number are drawn from the height of TKU girl students, and the number of a random number is 10,000, and we will see what happens. And here, sorry, the language is Chinese. It is I don't install. I don't install the computer. The operating system is not my decision to make. So don't complain. One and one and 10,000. A normal distribution, and average number. Hey, what is the average height of a TKU girl student? Let me suppose that it is 167. 167. And the standard deviation is 3.5. All right. So we have 10,000 random number drawn from the height, the population, and the population is the height of TKU girl student. Hey, the number one girl student has height 157. Number two has height 165. All right. Number 3 student has height 161, and you wanted to draw. You wanted to hey, how many students do we have? 10,000 students height. Here, you see that? 10,000. Okay, and hey, it is impossible to make a histogram plot manually. You need, in this case, you need to use the computer. You need to use the technology. Okay, the Microsoft Excel. All right, and again, data analysis here again. Histogram here, the histogram, right? I'm here. Here from the first one, the first cell to the 10,000th cell, okay? And the plot here. What? What happened? Oh, sorry. I forget to specify the class limit. We have to specify the class limit, okay? This is the class limit all the way to 180, right? That's the class limit. And from 150 to 180. Eh? Oh, sorry. I know what's wrong. This one, 10,000. 10,000. Yep, here and here. The first one. Sale A1. Okay, so we have 10,000. That's the distribution. Of TKU girl student. And right, and here, no space. And different color. You see that? Hey, how does it look like? It is also bell-shaped. The height of TKU girl student. Are you? Hey, this is also the shape of TKU girls' weight distribution. This time it is height, but if you draw the weight distribution using the histogram, it is also bell-shaped. Okay, most of the weight gather around the average rate, average height, average weight. Okay, gather around average number. Those who are very tall or extremely too low, too short, the proportion are very small. Or those who have was too heavy and those too light, the proportion is also small. Okay, most of the student have weight around the average height or average weight. Okay. So in statistics, we call this a simulation. A simulation. $10,000. And if you wanted to use more class limit, you want to use more class, then you can do 152 to make the class width smaller. More class to categorize them. Again, data analysis, histogram. And here the class limit is different. We have more cell, more bin to plot the histogram. Yep, here. And to customize, no spacing, and here, and also the lines. Yep, here. Okay. And in statistics, we call this distribution the normal distribution. All right. Okay, let me plot this. What? What happened? Hey. Hey. Oh my God. Where is it? Ha. This is not it. Again. Hi. Stupid computer. Here, no spacing between bins and the field. And then the borderline. Yep. All right. Copy. Copy. And paste. All right. Where's my pen? The histogram. Of TKU girl students. All right. And this is the class limit. All right. And this is the frequency count. Okay. The Professor Dan use Microsoft Excel to what? To generate 10,000 girl student heights. pseudo number. Pseudo means fake. As the 100 girl student height. Okay. So it is a random number. All right. And again, here we see again, bell-shaped again. All right. Okay. But we will be back to the example 2-2. Go back. Okay. Let's get back to the example we just use here. So what we have learned is the histogram. And now we are using the histogram to obtain a new plot. What is the new plot? The new plot is called frequency polygon. Polygon means the collection of some straight line segment. Okay, straight line. From histogram to frequency polygon. So how to obtain a frequency polygon based on the histogram you already have? Let's see. Let's go back to the example 2.2. Okay, so this is the histogram we just obtained. Hey, ignore the straight line segment. Hey, ignore the straight line first. Hey, remember this is the histogram of the 50 states record high temperature. Okay, this is 2 and this is 8 and this is 18 and this is 13. All right, all the way to 1. The histogram we just obtained. And when you have such a histogram, hey, we have how many bins? We have 7 class, so we have 7 bins. This 1, 2, 3, 4, 5, 6, 7. Hey, where is the mid bin position? Where is the mid bin location? Here, mid bin here. And what is the mid bin height? Hey, this is a bin, B-I-N. Okay, what is the mid bin height here? Mid bin height. Mid bin height. Okay, mid bin height, and you mark the 7 mid bin height. Okay, with a dot sign. DOT, dot sign. Hey, dot, you mark it. The mid bin height again, mid bin height again, mid bin height again, mid bin height again, mid bin. So you have how many? 7. And then the 9th one, add the one in the horizontal line here, and 1 here. So how many mark do we have? We have 9 mid bin value. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we connect every mid bin height by a straight line segment. Straight line segment, 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 straight line again, straight line again. And once we have how many straight line? 8 straight line here in this example. 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 7 straight line. Then the histogram is not needed anymore. Then all we need is this. That's the frequency polygon. All right. This is the frequency polygon. All right. You see that? So, hey, this is a frequency polygon of 50 states record high temperatures. And we call this frequency polygon. Poly means many, many in English. Guns means straight line, segment. And what is the purpose of a frequency polygon? We draw this, we draw this for a purpose, right? So what is the purpose of a frequency polygon? The purpose of a frequency polygon is, hey, same purpose as the histogram, is to visualize or represent the frequency distribution of a data set. In this example, the frequency distribution of the 50 states record high temperature. All right? And how is it obtained? The frequency polygons is obtained by joining two contiguous mid-beam heights with a straight line segment. Understand? So we go back to the histogram. By joining two mid-beam height, hey, here, can I have a, hey, can I borrow your pad? Yeah, no, pad, iPad, yeah, thank you. Suppose that this is a straight line, all right? And we connect this. We connect the two mid-beam height with a straight line segment. Hey, that's a straight line segment. Thank you. All right, and do two contiguous. Every two contiguous. Hey, these and these are two contiguous mid-beam height, and we join them by a straight line segment. Straight line, straight line, straight line, straight line, straight line. And once you obtain the frequency polygon, and the histogram is not needed anymore. All you need now for the so far is the frequency polygon. So which one is better? Hey, histogram. The purpose is of a histogram is to visualize the distribution, and so is the frequency polygon. The purpose of the frequency polygon is also the same as a histogram. Is also to visualize the frequency distribution of a data set. Hey, which one is better? Which one is better? Hey, raise your hand. Which one is better? Histogram, raise your hand if you feel histogram is better. Yep. Histogram, yep. You, histogram? And raise your hand if you feel polygon is better, frequency polygon. So what about the rest of the student? Are you sleeping? This one is conceptually simple, right? You like to see beans and bar something, in the histogram. You can easily get some idea, and the histogram also enjoy simplicity in construction. In its construction is simple, right? Okay. And the frequency polygon looks wiggy, wiggy, fluctuate from time to time. And but in statistics, this one can make a better approximation to the true distribution. Hey, this is a fake distribution, and so is the histogram. They are both fake distribution. But theoretically, which one approximate the true distribution better? Frequency polygon. Okay, and as a statistician, I can prove it. I can prove it by using the statistical theory. Yeah, use some mathematics to prove that frequency polygon approximate the true distribution better. Understand? Hey, which is better? Frequency polygon. In what? In which sense? In what sense? Because it can approximate the true distribution better, right? And which one is more conceptually simple? Histogram. Okay. Okay. And so this is a tool, and this is also a tool. And each tool has its strength and weakness. Understand? 有它的强项跟弱项。Okay? Understand? Hey, I don't use Chinese. Don't report to the administration I use Chinese. Okay? Yep. In statistics, comparison of two plots, two plots. Histogram is more conceptually simple. And more and easier to construct. Okay, but frequency polygon can approximate the true distribution better. Approximate the true distribution. Unfortunately, the true distribution is unknown. Okay? And maybe the comparison will appear in your midterm exam. Okay, the comparison. I mean the comparison. Will probably will appear in your midterm exam. Hey, when I say probably, some people might say possibly. What is the difference? Possibly, probably. Hey, probably or possibly. What is the difference in English? Hey, when you tell a girl, your girlfriend, we will probably go to the movie. I will probably take you to the movie. Then you should take her to the movie. Very likely, probably. And or it means you have a good chance. Good chance to go to see the movie. But when you say possibly, you may go to the movie or you may not go to the movie. 50-50, maybe or under 50%. The probability is under 50%. You can use, hey, the probability is lower than 50%. You can use which one? Possibly. Okay? Here I said probably means it is very likely to appear in your midterm. You have a good chance to make a comparison between the two tools. Understand? Hey, your boyfriend take you to the movie probably or possibly every time he says, which one? You don't know? Okay. What time is it? Okay. Let's go back to the textbook. And if you hey, let's go back to the example again. Go back to the example again. Here, I wanted to make the bin width smaller. I wanted to 149, okay, 150, because we have 151, okay, because we have 10,000 height, so all the way to 181. 181. So we have more bins, and each class has a smaller width. 181. Okay. So, and data analysis again. Hey, there is a tool here. Data analysis here. Now the class limit are different. Right? Yep, here. Yep. Okay. And copy. Let's make a copy. Copy. And paste. Here. So we have another histogram here. It is based on 10,000 observation, right? And the plot is more smooth than the record high than the histogram of a record high temperature. Can we draw frequency polygon this time? Of course, we can also have a frequency polygon based on this histogram, and this time you will see that the frequency polygon is smoother. than the previous one. Understand? Where is my pen? Can I have a can I have a scale? 借我尺. Yep. Yep, here. Mid-beam height. Mid-beam height. Mid-beam height here. Oh. Next one. Mid-beam height. Mid-beam height. Let me. Hey, 谢谢. Mid-beam height again. This time, histogram is a smoother, and so is the frequency polygon. Frequency polygon this time is also smoother. Smoother, 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 smoother. Okay? Okay. Here. And if you already have a frequency polygon, then the histogram is not needed anymore. Eh? That's the frequency polygon. This time, it is smoother. Is it smoother this time? Hey, is it smoother this time? Smoother means 更平滑. Understand? Why? Because you use more data, and you use more classes to draw the histogram, and then the frequency polygon. It is smoother. And hey, what are their purpose? They have the same purpose in common. The purpose of the histogram and also the purpose of the frequency polygon are the same. They are drawn to visualize the true distribution. Understand? Hey. Okay. Let's go back to the textbook. So we are now in section 2-2. Now it is time to plot the ogive. Hey, ogive. Where is the ogive? Here. Please go to page 59. The frequency polygon. based on 10,000 height and how many beans histogram? How many bean? 35 bean, 35 classes. Histogram of 35 classes, each with 1. Okay, this time the frequency polygon is smoother. All right. Okay. Now go back to the now let's go back to the example 2-4. Okay. Now record high temperature. Okay, record high. And then I need this. What do I need? I need this. Yep, here. Here. Okay. I think I had a better screenshot this one here. All right, and paste. All right. Hey, this is the frequency count. This is the frequency count. And this is the count of every frequency. They are the frequency count of the first, the frequency count of the second class. What if we add them up here? Now we don't need this. And we don't need this. All we need is one more column on the right hand side. Yep, here. And now we call this a cumulative frequency. Okay, up to 104.5, it is the frequency count is 2. And now up to 109.5, it is 10, which is equal to 2 plus 8. And up to 109.5. And up to 14.5, it is 28. All right. And what about this? 28 plus, it is 41. And 48, and 49, and 50. So all we need is one more column. What happened to the what happened? What time is it? Ah, okay, well, we have only 3 minutes. I will plot the ogive. What is, how to spell? Ogive. We will use this to plot the ogive next week. What happened to my device? Ah, it's that. Ah, ah, hey. Don't panic. Don't panic. Hey, Rocco, I will still do the Rocco. Ah, let me write it here. What happened? Okay, roll call time. Please. I haven't saved the file. Please. Roll call time. What happened? Oh my God. I be patient. This time, the code is. Hey, don't pass the code. Oh my God. Oh my God. Oh, I have to save the file. Okay. See you next week. Hey, don't complain if I cannot provide the file this time. Yep.
The class is full, right, in the computer?
What?
The computer one, the one that I told you just now.
It just went wrong. I don't know. I will. Maybe I will. This time I cannot save the file.
So basically,
Yes.
this is your class, right? It says it's full. So next.
Full?
Yeah, it's full.
Why?
I don't know. It's full here. So like.
Oh. Full.
Yours, right?
Yeah.
Full. So
Yeah.
can I still enter it even though it's full?
Oh, I don't know. I don't know. Maybe you can apply manually, not on the internet. Maybe I make a call to the administration. All right. What is your name?
刘冠亮，刘冠亮，
Liu.
冠亮。
What is? How do you? Can you write it? 你们要找我吗？哎，Can you write it on the board? Yep, yep. 哦，可以啊，可以啊。你是哪一班？哦，那念统计干嘛？大船要念统计。哦，要民调，要啊。好，欢迎啊，欢迎哦，欢迎。哎，他说已经满了，但是你把你们的名字写一下，然后我可能用那个手动的方式去问学校。哦，OK，刘管亮。I will ask the administration. Where are you from? Oh, and I mean the country. Oh, okay. Oh no, thank you. Shit.